The 32 gigawatts of offshore wind for the UK, recently announced by the Crown's estates as round 3 of their offshore wind programme, ensures that the UK stays ahead of the game. But this hugely ambitious project will be fraught with both engineering and financial challenges if it is to succeed.
The UK offshore wind round 3 is an absolute critical piece of the low carbon puzzle and fundamental to the country's ambitions to achieve its 2020 carbon reduction targets as set by the EU. The background figures are well known, but bear repeating as they are at the core of the dizzying array of policy that is being churned out at both national and European level. The UK has been set a target by the EU that 15% of our energy use be delivered by renewable sources. At present, the 3 biggest categories of energy use are transport, which is 45%, gas and heating at 33%, and electricity generation at 19%. However, not all sectors have the same scope for reduction, so it is clear that the strategy is for electricity generation to bear the brunt of the demands, and will have to deliver almost 40% of our electricity generation needed from renewable sources by the end of the decade.
We expect that around 40% of electricity will have to come from renewables by 2020, and the bulk of this is going to have to come from offshore wind. There are other renewable energy sources that can deliver some of this, like onshore wind, but they have constraints. Also, marine energy is a technology that has its place, but that's something that's likely to be more important after 2020. So offshore wind is the one that can deliver the greatest amount of renewable electricity. We expect it can deliver something like 25% of the UK's electricity by 2020. And to put this into perspective, it requires installing something like 29 gigawatts of energy, and at the moment there's around 80 gigawatts of electricity capacity in the UK.
There cannot be many people by now that have not seen an onshore wind farm, and they are quite impressive in scale. But these structures will be dwarfed by the massive offshore turbines that will need to be constructed over the next 10 years. The operating areas that the round 3 sites are offering are extremely challenging for a number of reasons, but particularly the water depth and the distance from shore, 2 factors that are completely different to the offshore farms that we have seen in the UK and elsewhere in the world to date. It is estimated that around 29 gigawatts of capacity is required by 2020 to deliver the 40% renewable target. This equates to around 75 billion capital expenditure, the equivalent of building around 8 channel tunnels over the next 10 years. Getting the proven technology in place over the next couple of years will be vital, because technology choices will have to be made by the developers by 2013 for the first developments. There isn't much time for offshore development before then, and it is vital that the technology is tried and tested, as developers will not install unproven technology.
The depth of the sites in round 3 are much deeper than they were in the previous sites. Up to now, the wind farms have been in depths of up to 20 metres. 2/3 of the capacity is in depths of up to 20 metres. But for round 3, 70% of the capacity is going to be in depths of more than 30 metres. So that means that you need much larger structures. So the kind of structures that we're going to need will be very large. They're going to be larger than, for example, the Gherkin building in London. They're going to be 230 metres tall, of which 30 metres is below the surface of the seabed, 30 metres of water depth, and then a further 170 metres from the sea to the top of the blade.
Almost all of the wind farms that operate or are in construction around the coast of the UK use monopile foundations. The advantage of these is that they are a tried and tested technology that has been used for some time in marine construction, both by the offshore wind industry and before them by the oil and gas sector. At their most basic, these are simple steel tubes that are hammered into the seabed. However, as we move into deeper and deeper waters, these structures have reached the end of their useful life. Monopiles cannot be used in water that is deeper than 30 metres, or with turbines that are rated at 3 megawatts or greater. In mind of these constraints, the wind industry has been considering its options. In October 2008, the Carbon Trust set up the Offshore Wind Accelerator with the objective to reduce the cost of offshore wind by 10%. The 30 million RD&D programme is being delivered in collaboration with 5 major offshore wind developers: Airtricity, Dong Energy, RWE, Scottish Power Renewables and Statoil. The Carbon Trust identified 4 extremely promising areas to focus on: foundations, access, electrical connections and wake effects. Of these areas, the work on foundations is considered to be of prime importance.
The Offshore Wind Accelerator is trying to reduce the cost of energy of offshore wind to ensure that the economics of the project work, and so that we have the best chance of realising the potential of offshore wind. And foundations is one of the 4 areas that we're looking at. We ran a competition last year to get experts from other industries to look at the challenges of foundations, because foundations represent almost 50% of the capex involved in an offshore wind farm. Now, we got over 100 applicants from many different backgrounds, especially from the oil and gas industry, and this has led to 7 concepts that we think have a real opportunity for reducing cost. We expect they could deliver cost savings of more than 20% on foundations. The keystone structure is a structure that was used by the oil and gas industry in Houston, not for offshore wind, but for oil and gas. And it's a very robust technology that's been proved in Hurricane Katrina and withstood that. And the advantage of this technology is that it uses far less steel than normal jacket structures, and it's easier to install. So because you use less steel and it's easier to install, it can deliver significant cost reduction. The Gloucester structure is a floating structure, and so it's suitable for deeper water. If you can have a floating structure, it means you have less foundation involved, and so you have less material, and it's cheaper, and it means that you can go to much deeper water than you can with conventional structures. The SBT Wood Group is an interesting concept because it's a concept that can be assembled in the benign conditions of a port. So you build the whole structure, which is the wind turbine plus the foundation, in port, and then use a normal barge to take it out to where it's going to be installed. At that point, it's sunk to the seabed, and then suction buckets secure it to the seabed, so you don't need to do lots of drilling into the seabed. The Gifford device uses a concrete gravity base rather than steel, which is commonly used in the monopiles that you see in offshore wind farms today. And the advantage of concrete is it's cheaper than steel, and therefore you get your cost saving from that.
The Carbon Trust expect 2 or 3 of the devices to be demonstrated by their partners over the next 2 or 3 years, and that the shortlisted concepts can reduce the cost of the foundations by 20%. This will be a saving that will be crucial to the financial success of offshore wind.